So we have one last section to talk about with our identities, and this section is referred to as the half angle section. So instead of deriving the formulas, we can read that in the book. We end up with this. Cosine of A divided by 2 is plus or minus 1 plus cosine of A divided by 2. And the way that we determine whether it's going to be positive or negative is the location of A over 2. Similarly, the sine of A over 2 is plus or minus the square root of 1 minus cosine of A over 2. One of the reasons that these formulas look so similar to each other is we found both of them by doing something pretty ingenious. If we look, we know that cosine of 2A is equal to 2 cosine squared A minus 1. So if instead I let x over 2 equal to A, then what I have here is cosine of A is be 2 times x over 2 would be x equals 2 cosine squared x over 2 minus 1. So if I solve that now for x over 2, I have 2 cosine squared x over 2 equals 1 plus cosine of x. Cosine squared of x over 2 equals 1 plus cosine x over 2. Take the square root of both sides. Cosine of x over 2 equals plus or minus the square root of 1 plus cosine x over 2. Okay. Similarly, we get the formula for sine of A over 2. Because cosine of 2A is 1 minus 2 cosine squared, cosine of 2A is 1 minus 2 sine squared A. And we could use that formula again. So we've got these two formulas that if you look at them, they're very similar. Cosine of A, the formula is 1 plus cosine of A. And I sometimes remember that because I focus on it's positive because it's the same function. Sine of A over 2 is 1 minus cosine A over 2. Look how close these two formulas are together. The only difference is the plus and the minus. Finally, of course, we have a formula for tangent of A over 2. And tangent of A over 2, interestingly enough, tangent is sine over cosine. So if we took these and divided, then the denominators would cancel. And so one of the formulas we see for the tangent of A over 2 is 1 plus cosine of A over 1 minus cosine of A. We just divide the two fractions from above. And actually, tangent is not cosine divided by sine. Tangent is sine divided by cosine. So this would be a subtraction and this would be a addition. And we still have the plus or minus that we have to determine by knowing where A over 2 is. We can also simplify these, or not simplify those, but we get other forms. One option is sine of A over 1 plus cosine A, and another option is 1 minus cosine A over sine of A. So we're going to do just a few simple problems with this section to make sure that we understand what's going on. One question we might be asked is to find cotangent of theta over 2 if tangent of theta is equal to negative square root of 5 over 2 and 90 is less than theta is less than 180. Notice what's going on here. In this case, theta is between the end of the first quadrant and the end of the second quadrant. So theta is in quadrant 2. And if we divide by 2, 45 is less than theta over 2 is less than 90. So we can see that theta over 2 is going to be between 45 and 90 degrees. Now, I don't have a half angle formula for cotangent, but I know that cotangent of theta over 2 is going to be the reciprocal of tangent of theta over 2. So one of the things I really need to do here is to find the tangent of theta over 2. Another interesting thing to notice, though, is none of my formulas for the half angle of tangent involve anything other than sine and cosine. And for some reason, this problem only gave me the tangent value. So what I have to remember is my Pythagorean identity that involves tangent, and that is tangent squared of theta plus 1 equals secant squared of theta. If you forget that one, you can always go back to cosine squared theta plus sine squared theta equals to 1. Tangent is sine divided by cosine. So over here, I need to divide everything by cosine squared theta so that I can get tangent. So there's my tangent, there's my 1, and there's my secant squared theta. So tangent of theta was negative square root of 5 over 2. So if I square that, I'm going to get 5 over 4 plus 1. I'm going to think of my 1 as 4 over 4. And that's equal to secant squared theta. So 9 over 4 is equal to secant squared theta. So secant of theta is going to be the square root of 9/4, which is 3 over 2. I took the square root, so I want plus or minus. But instead of going ahead and writing both of them, theta was between 90 and 180. That is in quadrant 2. In quadrant 2, sine is positive and cosine is negative. Secant is the reciprocal of cosine, so secant is negative. Also, nice for me to know, I just said secant and cosine are reciprocals, so if secant is negative 3/2, then cosine of theta is negative 2/3. I could find the sine value, but there's a formula for tangent of a over 2 that involves only cosine. So tangent of theta over 2 is going to be, according to my formula, I want plus or minus, but theta over 2 is in quadrant 1, and in quadrant 1, tangent's positive. So I've got positive. So I have 1 minus my cosine value, which is negative 2/3, over 1 plus my cosine value, which is negative 2/3. I'm going to simplify. I'm going to think of my 3 as 3 over 3. I subtract a negative 2, so that gives me a positive 5. So my numerator is 5/3. 1 I still think of as 3 over 3, plus negative 2/3 gives me 1/3. So under the radical, I've got this division, and I know that I multiplied by the reciprocal. And so this simplifies to the square root of 5. So the tangent of theta over 2 simplifies into square root of 5. So I'm running out of paper here. So tangent of theta over 2 was the square root of 5. So the cotangent of theta over 2 is going to be the reciprocal of the square root of 5. I now need to rationalize. So I get the square root of 5 over 5. Now we're not going to do a large number of problems from this section. 19, 21, 23, 25, 27, 29, 45, 47, 49, and 51. And the good news is this is our last section of identities.